This is Math 2 4.1a notes. That's Unit 4, Lesson 1a. You should have received this handout in class. If not, or you misplaced yours, you can always print it off from my website. Alright, I've already plotted the points, connected, made my triangle, and I've highlighted the formulas we are going to be using. These three formulas you will need on test day. They will not be printed for you like this. These are formulas you've used in the past, so you should know them. You just got to refresh and have them memorized for the test. Alright, the mid-segment of a triangle is a segment joining the midpoints of two sides of a triangle and is parallel to the third side and half the length of the third side. Okay, so that is not new. We've done that in a previous lesson, so it should look familiar to you. Okay, so I'm just going to put it up here really quick. These are the notes we did before, and we talked about you double the mid-segment, it equaled the base. And that's what we're going to be proving on this worksheet. Mathematically, geometrically, we're plotting points and going to prove it. Okay, so plan, create a triangle on the coordinate axis, label the three vertices of the triangle with letters and with coordinates. We've done that already. Find the midpoint of JL. So when you're taking the test, you want to be very organized. I'm going to model for you what I want to see. I want you to label, and yes, you do have to label the points you're using. When you mess up, if you mess up, I don't want to have to try to figure out what's where, so you label. J and L on every single one, you label the points you're using. J is 0, 0, L is 4, 6. Okay, so midpoint of JL. Oh, and they asked us to call this point M. Okay, so point M, it's pretty much the average of the x values and y values. I add the x values, so 0 plus 4, and cut them in half. I add the y values, 0 plus 6, and cut it in half. 4 over 2 is 2. 0 plus 6 is 6 over 2 is 3. So box that in, again, because on the test, when I'm grading, I don't want to have to look and figure out where all your answers are. M is 2, 3. So we're going to plot that. 1, 2, 2, 3. We're going to label it M, and 2, 3. Okay, next piece. Find the midpoint of LK. JK, sorry. Find the midpoint of JK and label it N. Okay, so again, you have to label the points that you are using, J and K. J is 0, 0, and K is 6, 2. And this is exactly what I want you to be doing as well. And then they asked us to label this midpoint N, and I'm going to add my x's, 0 plus 6, divide by 2, and add the y's, 0 plus 2, divide by 2, and that gives me 3, 1. So let's plot that. That's that point right there. And I changed it to M. I apologize. That is still point N. N is 0.31. And connect. That there is the mid-segment. Okay, so what we're going to try to prove right now is that these two lines here are parallel, and that if you double this one, it equals the base side. They call it the third side. I've called it the base side. Or if you cut the base side, the third side in half, it'll equal the smaller mid-segment. Okay, so that's what we're going to try to prove now. How do we prove lines are parallel? By their slopes. If two lines have the same slope, then they are parallel. I'm going to break this little piece in half, and again, when you're taking the test, that's exactly how I want you to do it. Find the slope of each segment to justify mathematically why this is true. So we're going to find the slope of MN and LK. So on this side, I'm going to do the MN. Here's the M, here's the N, and on this side, I'm going to do the LK. So again, keep everything nice and neat and labeled. M is, where's my M? 2, 3. And N is 3, 1. L is 4, 6, and K is 6, 2. And I can't emphasize how important it is when you're doing this on your own to label everything properly, so it's when I'm grading, I'm not having to figure out where all your work is and what you were doing. Okay, slope of MN. Slope of MN, you take the difference of the y's, y2 minus y1, over the difference of the x's, x2 minus x1. You have done this in previous classes. I'm going to start with the one on the right, 1 minus 3. 1 minus 3 over the x values 3 minus 2. As long as you're consistent. So if you started on this side and did 3 minus 1, that's fine, but you would then have to do 2 minus 3, as long as you're consistent. That 1 minus 3 is negative 2, 3 minus 2 is 1. My slope is negative 2 over 1. All right, slope of LK is what we're going to do on this side. Equals 2 minus 6, because those are the y values, over 6 minus 4. 2 take away 6 is negative 4. Now right now that's not equaling, so let's see what happens. Over 6 take away 4 is 2. That does reduce. I can divide top and bottom by 2. That gives me negative 2 over 1, and sure enough, the two slopes are equal. If the slopes of these two lines are equal, that means that these two lines are parallel. And that's how I show that they are parallel. So right now, we just proved the first part, prove the lines are parallel. All right, next piece, we're going to prove that the third side is half the length, I'm sorry, where is it at? And half the length of the third side. That this is half the length of the third side. Or this is double the midsegment. It means the same thing. Okay, distance formula. Do the same thing, separate your paper into two because we're working with two segments here, two lines. We're working with MN, which we just did up here, and we're working with LK. Okay. The difference of the x's, x minus x, quantity squared, and you can do the same thing, x2 minus x1 like we did up here, y2 minus y1, and you can see we've done it already. So make sure you label your points, M and N. M is 2, 3, and N is 3, 1. And I'm going to come back up here because I did forget to box my N in, so please do not do that. And then LK. L is 4, 6, and K is 6, 2. Okay. Distance equals, don't forget it is a big square root, and then I'm going to put, like, I call it the skeleton of my formula. You know what the skeleton looks like? You can set that up and figure out what goes inside. The difference of my x's, the difference of my y's. Because it's addition, if you did your y's first, that is perfectly fine. Someone put a little note here. If you did this, y2 minus y1 squared, and then x2 minus x1 squared, it doesn't matter because it's addition. So if you flip-flopped them. Some kids like to because they just did the y2 minus y1 here and the x2 minus x1 there. It's up to you. I'm going to follow the formula. So 3 minus 2, and then 1 minus 3. 3 minus 2 is 1, plus 1 minus 3 is negative 2. And 1 times 1 is 1, plus 2 times 2, negative 2 times negative 2 is 4. There's still a square root. And my distance equals the square root of 5. Distance equals, for this one, big square root. And just to show you it works either way, I'm going to flip it. I'm going to do this one with the y's first. So 2 minus 6, and then x minus x would be 6 minus 4. And again, you can see we just did that here. 2 minus 6, 6 minus 4. 2 minus 6 is negative 4. squared. 6 minus 4 is 2 squared. Square root, you do not square individually. You have to square them, add them, and then simplify. What do we get? Square root of negative 4 times negative 4 is 16, plus 2 times 2 is 4. 16 plus 4 is root 20. Now, how that doesn't look like 20 is twice as big, or that root 5 is half the size, but we've not yet simplified this. So we're going to think back to, it was the first week of school, we talked about how to simplify radicals. Do you remember when we did the factor tree and broke things down, the prime factor tree? 4 times 5, 5 is prime. 4 is 2 and 2, which are both prime. 2, 2, and 5. I take out the pair. It leaves me with 2 root 5. So, root 20 is equivalent to 2 root 5. So, we just proved that the base, the third side here, is twice as big as the midsegment, which is equivalent to saying the midsegment is half the size of the bigger piece. Root 5 is half of 2 root 5. Okay, the length of MN equals, where's my MN? That's this one, root 5. The length, nope, they want us to write down what is going on. The length of MN is blank the length of LK. Okay, the length of MN is blank the length of LK. It is half. Can you see that? Root 5 is half of 2 root 5. The length of MN is half the length of LK. Explain mathematically from your work in Part E why this is true. You can see that MN equaled root 5, which is half the length of LK, which was 2 root 5. And you can show that here. If I were to take 2 root 5 and cut it in half, I'd reduce it and get root 5. Half of 2 root 5 is 5. Okay, that is it for this lesson. We'll work on this together in class.